Hello everyone and welcome to my channel Ghiloo once again. So in this video I'll be discussing the entire exercise 5.7. From question number 1 to 10 we need to find the second order derivatives. So without any further delay, let's get started. So just a brief introduction about second order derivative. Suppose f of x, this is a function. The derivative of this function with respect to the variable it is with is called the first order derivative, and the derivative of this first order derivative is called the second order derivative. It can also be represented by d square f of x by dx square. So what we're going to do, we're going to differentiate it twice, that's all. So let us start with question number 1. Let y is equal to x square plus 3x plus 2. Therefore dy by dx is equal to 2x plus 3 and d by dx of dy by dx, that is equal to d square by dx square, that is equal to simply 2, because the differentiation of dy by dx, the differentiation of 2x plus 3 is 2. Therefore the second order derivative of x square plus 3x plus 2 is 2. Analytically it can also be represented as the rate of change of slope of a function. The slope is dy by dx and the rate of change of slope is given by dx of dy by dx. So similarly I won't be writing any of it, I will just be solving x to the power 20. First order derivative is 20 x to the power 19, as you know the formula. Now the second derivative will be differentiation of 20 x to the power 19, that will be giving you 20 times 19, that is 380 x to the power 18. Similarly, coming to question number 3, that is x cos x. So you know that it is the multiplication of two functions, so obviously we'll be having the product rule here. So first let me keep x and let me differentiate cos x, plus let me keep cos x and the differentiation of x is x itself. This is the first order derivative. So the first order derivatives comes out to be cos x minus x sin x. Now once again differentiating it would be giving me the second order derivative, right? So what can I do? The differentiation of cos x is minus sin x, and here for x sin x, once again it is the product of two functions and we need to apply the product rule. That is going to be x times the differentiation of sin x is cos x plus sin x, let us keep it as it is, and we are getting the differentiation of x with respect to x to be 1. Since I have taken the minus already common, so the result was not affected much, but the final answer will be sin x minus x cos x minus sin x, that will be minus x cos x minus 2 sin x. And in this simple way you will be just differentiating, that's all. You just have to have the proficiency of differentiation. Now log of x, the first derivative of log of x is 1 by x, and the derivative of 1 by x, that is x to the power minus 1, is simply equal to minus 1 x raised to the power minus 2, that is by x square. This is the second order derivative. Coming to question number 5, that is x cube log of x, once again in the same way as we did it question number 3, x cube times log of x. Let us differentiate it once and we will be getting x cube times 1 by x, keeping x cube, plus keeping log of x, we are getting 3x square. So x and x cube cuts to be x square, so the result is x square plus 3x square log of x. Now you can do it in two ways. The best way is to take x square common out of the expression and then apply it as a multiplication of two functions. So differentiating this, let us keep x square at the first place and then let us differentiate it simply. The differentiation of 1 is 0 plus 3 log x means 3 by x, plus now let us keep 1 plus 3 log x as the function and let us differentiate x square, that is 2x. So the final result will turn out to be, this is simply 3x square by x, that will be 3x plus 2x plus 6x log x, that is equal to 5x plus 6x log x. As simple as that. Now coming to question number 6, in the same way, it is e to the power x sine of 5x. Let us differentiate it once by the product rule and we get it as e to the power x times sine 5x means 5 cos 5x plus sine 5x times the differentiation of e to the power x is e to the power x itself. Now the best way is to separate e to the power x out, and let us write it by sine 5x plus 5. This is 5, alright. 5 cos 5x. Now let us differentiate it once again. Let e to the power x be one function and the entire thing in the bracket be the second function. So let us keep e to the power x first, then differentiate it. I'll be getting 5 cos 5x plus the differentiation of 5 cos 5x will be 5 times minus 5 sin 5x by the chain rule, plus now let us keep this function sin 5x, this function sin 5x plus 5 cos 5x as it is, and differentiate it to e to the power x with respect to x, that will be e to the power x. So it turns out that there is no change in this function, so you can arrange it in your way to get the final result. And in the same way as question number 7, so I'm not repeating the same thing. Question number 8, there is tan inverse of x. In question number 8, tan inverse of x, one time differentiation of tan inverse x, if you can remember the differentiation of inverse trigonometric functions, you get it as 1 by 1 plus x square. The differentiation of 1 by 1 plus x square once again is by the uv rule, where this is u and this is v. So let us differentiate it once again. That will be v square, means 1 plus x square whole squared. Now 1 plus x square times differentiation of 1, that is 0, subtracted by 1 times the differentiation of 1 plus x square, that is 2x. So it turns out to be minus 2x by 1 plus x square whole squared. And this is question number 8. Similarly, in question number 9, it is log of log x. Let us differentiate it once. Obviously we'll be applying the chain rule, so that is 1 by log x times 1 by x, so that is 1 by x log x. If you don't understand, the differentiation of log x is 1 by x. So here let us assume this something, so differentiation of log of something is 1 by something times the differentiation of something, that is 1 by x. So 1 by x log x, let us differentiate it once again. So what will be getting? Nothing, just this is u by v once again. So this is x log x whole squared. Here it will be 0 as was in the previous case, 1 times the differentiation of x log x, that is x times 1 by x plus log x. So that will basically be minus of 1 plus log x by x log x whole squared. And finally in question number 10, that is in the same way. Let me come to question number 10, that is sine of log x. Sine of log x, so by chain rule it will be cos of log x divided by x. That means cos of log x times 1 by x, because cos of something, the differentiation of sine of something is cos of something, and once again we need to differentiate that something. Now differentiating this expression, this is clearly in the form of u by v, so we need to have the division rule here applied. That will be giving me x square. Now x times the differentiation of cos of log x, that is minus of sine log of x by x, minus cos of log of x, the differentiation of x, that is 1. So that is the simple answer we get, that is minus of sine of log of x plus cos of log of x by x square. This was up to question number 1 to 10. Coming to question number 11, we're given if y is equal to 5 cos x minus 3 sin x, prove that d square y by dx square plus y is equal to 0. So this is a damn easy question. You don't have to even lift your pen for that, but in your case I am doing this. Given y is equal to 5 cos x minus 3 sin x, let this be equation number 1. Now dy by dx, let us find it. What it is? It is 5 of minus sin x minus 3 cos x. Okay, now differentiating this, we will be getting d square y by dx square, that is equal to d by dx of dy by dx. Now what was dy by dx? That was minus 5 sin 3 sin x minus 3 cos x. So basically that will be giving us minus 5 cos x plus 3 sin x. Now if we take minus common from here, it will be 5 cos x minus 3 sin x. Now if you can remember, 5 cos x minus 3 sin x is y, so this is equal to minus y. I'll be writing from equation 1. So therefore d square y by dx square is equal to minus y, which implies that d square y by dx square plus y is equal to 0. Proved. Okay, so I'll not be repeating the process, and in the same way I'll be continuing from question number 12. So in question number 12 we have y is equal to cos inverse of ax, and we need to find d square y by dx square, the second derivative of it in terms of y alone, means there should be no other variables involved in the second derivative of it. So let us try to solve. See, if y equal to cos inverse of x, that means automatically that cos of y is equal to x. Let us keep it as it would be necessary in future. So let us differentiate it simply. As you know, the differentiation of cos inverse x is minus 1 by root over 1 minus x square. So basically that is equal to minus of 1 minus x square raised to the power minus half. Now let us once again differentiate it. D square by dx square, that is equal to d by dx of dy by dx. So basically that is equal to d by dx of minus 1 minus x square raised to the power half, minus half. So by chain rule you need to solve it. That will be equal to minus of minus half times 1 minus x square raised to the power minus half minus 1 times the differentiation of 1 minus x square, that is going to be minus 2x. So finally this comes out to be minus x by root over 1 minus x square whole cube, that is minus 3 by 2, as you can see. Now as you can see that cos y is equal to x, let us replace all the x by cos y. So that is going to be minus cos y by root 1 minus cos square y. This was really necessary because it was what is needed. Solving this, I'll be getting cos y by root of 1 minus cos square is sin square y. So that is equal to sin square y to the power 3 by 2. Now sin square y and root will get cancelled, and what I'll be left with is only cos y by sin cube y. Now I can divide it as per my convenience. This is the answer, but anyways, if I want to do a little bit of engineering in it, so I'll be doing cos y by sin y. The remaining term is multiplied. So that is basically equal to minus cot y times cosec square y. This is what we were needed, and this is the required expression. So in this way you can just manipulate here and there and you can solve the questions. So coming to question number 13, we have y is equal to 3 cos of log x plus 4 sin of log x. Now here we need to understand one thing. Sometimes instead of putting d square y by dx square dy dx, always we can represent it by y1 and y2 y3 respectively. What is y1? y1 is differentiation of y with respect to x once, that is the first derivative dy by dx. y2 means d by dx of dy by dx, that is the second derivative. y3 means the third derivative, the third order derivative. This is the way it is proceeded. So basically here we need to show what? Nothing but x square d square y by dx square plus x dy by dx plus y is equal to 0. So basically what we are needed to find? We are needed to find dy by dx, then we need to find d square by dx square, and then put the expression in LHS and find it equal to be 0. So basically you just need to solve it, find dy by dx, then differentiate this expression once again to find d square by dx square, and then put it in the expression, and you will for sure be finding 0, it to be 0. This is how you can prove. Similarly, question number 14 is the same. You have the expression for y. So what you will be finding, you need to show this expression to be true. So it's very basic. For question number 14, first you are going to find dy by dx, then you need to find d square y by dx square, then you just do nothing but put the expression in LHS and you will be inevitably getting it equal to be 0. In this case It is a very easy one, deals with only exponential functions, and that's all for question number 14. Similarly, in question number 15, if you can see, it is just solvable without even putting the pen on the paper. So 500 and 600, these are constants. This is a follow-up of question number 14. So here basically, if we differentiate it twice, we'll be getting the 7 twice here in front. So basically it will be equal to 49y. Let us see what it is. 500 e to the power 7x plus 600 e to the power minus 7x. Let us differentiate it. So we'll be getting 500 into 7 times e to the power 7x plus 600 times minus 7 times e to the power minus 7x, as you know by chain rule. Once again, if we differentiate it, d by dx of dy by dx, that is equal to d square y by dx square. So that will be equal to 500 times 7 raised to the power e to the power 7x, because all other are constants, and here it is 600 times minus 7 times e to the power minus 7x, because these are all constants and we are playing with it. So inevitably you have 500 times 49 e to the power 7x plus 600 times 49 e to the power minus 7x. So you just take 49 common out of this expression and have this as y, the expression you started with. So you can clearly see here that d square y by dx square is equal to 49y. This is how easy it is. And in the same way you are going to proceed with question number 16. The only difference is question number 16 is an implicit function, so you can just differentiate it as it is. So in question number 16, either you can break it or you can differentiate it right away. I'll be differentiating it right away. We have the expression e to the power y x plus 1 is equal to 1. Let us differentiate it, let's say with respect to x. So since this is a product of two functions, let us keep e to the power y once and differentiate it with respect to x. I'll be getting 1 plus, let me keep x plus 1, and I'll be getting e to the power y times dy by dx, and this will be equal to 0. So therefore I'm getting e to the power y plus x plus 1 e to the power y dy by dx equal to 0. Now you know that e to the power y times x plus 1 was equal to 1. So basically dy by dx is equal to minus e raised to the power y, because the entire value of this expression is 1, as we know here. Alright, now once again, if we consider the double derivative of it, so d square by dx square, that will be equal to minus e raised to the power y times dy by dx. Now this is a bit tricky one. You know that minus e raised to the power y is nothing but dy by dx. So this is equal to dy by dx times dy by dx, which gives you, this is d square by dx square is equal to dy by dx whole squared. This is all about question number 16. And in the same way you can do question number 17. It's also an easy one, just you have to apply chain rule continually. You need to find the first order derivative, from there you need to find the second order derivative and just put this in the expression, and you will be getting the value as 2 by reducing the expression. Let's keep up to this today. In the next video I'll be discussing exercise 5.8. Thank you very much for watching the video.